All right, guys, let's start off with number 8. Okay, so we got to factor completely. Remember, our factoring methods are GCF. That's the one you'll always try first. Then we got diamond, snowflake, and then factor by grouping. So just as a reminder, this is all in previous notes. GCF, you always want to try. We're trying to divide something out from every single term. X method, you have to have the quadratic pattern, which I call the ABC pattern. Same thing here, ABC pattern. For this guy, your A is equal to 1. For this guy, your A is not equal to 1. And then factor by grouping, you have to have 4 terms. All right. So based on what I just said, we're going to try GCF first. So can I divide a number from all of these? And the answer is, you always look at the smallest number. What can divide the smallest number? And that's 2 and 1, or 1 and 2. Can 2, starting with the biggest number on this list, can 2 divide all of these? And the answer is no, it cannot divide 7. So GCF's out of the question. And then I recognize that I actually have 4 terms, so it's going to be factor by grouping. And if you recall, factor by grouping is where you split this into 2 problems. Okay, we're going to GCF here. All right, so the GCF here, what's the greatest common factor, the biggest number that can divide 28 and 8? And that's going to be 4. Okay. So 4 is the biggest number that can divide both 28 and 8. And then they both have a variable, the same variable, so we pick the lower power one. D squared is going to be my GCF. So now we're going to divide by our GCF, which is 4D squared. 4D squared. And then let's do this math. 28 divided by 4, 7. D to the third, divide out 2 of them, we're left with 1. 8 divided by 4 is positive 2. D squared, divide out 2 D's, or D squared, that leaves you with none. So it cancels. We have this, and then our GCF goes in front, 4D squared. Okay, now we're going to do the same thing over here. What's the biggest number that can divide out of here? All right, and the answer, when you're doing factor by grouping, you have to have a GCF. So the only thing that can divide both of these is actually 1. Since this guy is, the first guy is negative, our GCF here, we put it on top, is gonna be negative 1. Because we want the first guy, we can't have a negative here, so we divide out a negative. And the only number that divides both is 1, so negative 1 is gonna be here. They do not have variables in common, so we're just going to divide by negative 1. That's my GCF. So it's going to be 7D plus 2. And negative 1's my GCF. If you're doing this right, the parentheses should be exactly the same, which we are. We're now going to regroup. So 4D squared minus 1 goes in its own parentheses, so the GCFs go in its own parentheses. And then we have the parentheses that match, they just come together in one parentheses, 7D plus 2. Cool, so we did factor by grouping, but remember we have to factor completely. So now we gotta check, can I use one of these? All right, so is one of these things, these factors in parentheses, qualify for the ABC pattern? If you look at this parentheses, the answer is no, because we have to have an even power. This is D to the power of 1. This is an odd power, so this cannot factor. This has an even power, which means it probably can be one of these, but to make sure, we just are going to check. If anything, since it's an even power, this is my A. The guy at the end without the variable is your C. And if the middle guy is missing, our B. He's not there. Okay? So we're going to rewrite them so he's ABC pattern. Because we do have an even power, highest power is even, we got to try one of these guys, one of the snowflake or diamond. So we're going to have A is 4D squared. My B is missing, so we're going to skip it for now, and we have our C. So to put our D in when it's, or put our B in when it's skipping is 0, and then the single variable of D. So here's my A, here's my B, my C, and because the A value is not 1, it's not 1, not equal to 1, we're going to use snowflake. So let's snowflake this guy. A times C goes on top, that's -4. B goes on bottom, that's 0. Your A value goes here and here. So 4, 4. And then we split the D value, D and D. And now we try to find our magic pair. What multiplies the -4? That adds up to 0. That should be fairly easy. It's -2 and 2. And then we check, can I reduce this? Yes, I can reduce by 2 here. So we're going to reduce by 2. That gives me 2D on top and -1 on bottom. Same thing happens over here. I can reduce by 2. That gives me 2D on top and +1 on bottom. So once I have that, I can put those into factored form. So we're going to have 2D minus 1, and then 2D plus 1, and then don't forget your factor up here. 7D plus 2 goes here as well, all 3 factors. Okay, that is now factored completely. All right, I'll let you do number 9 on your own. If you're having trouble, check the answers or hit me up on the office hours, okay? All right, number 10. We want to check, is x equal to -6 a 0? All right, so if you remember, this guy is in answer form. Okay, and what we're trying to figure out is, what will his remainder be? We want to know, will his remainder be 0? Okay, so remember, 0 means he has a remainder of 0, but 0 also means solution. So is -6 a solution? Is it a root? These all mean the same thing. So if you have a question, hey, is -6 a root? You're going to do the same process. If it asks, is -6 a 0 or a solution? You do the same process, okay? So what I'm going to do is show you 2 different ways. Last Zoom, we used synthetic division. So I'm going to show you synthetic division. Okay? Because both of these processes involve answer form. So notice my root or my 0 is in answer form. Okay? If you're confused on what I'm talking about, watch last Zoom. It's recorded. Go back to Canvas and watch it, okay? We're going to use synthetic division one way, or we can use the plug-in method. These methods only work for when you have answer form. The plug-in method is what is on the Monday notes. They use the plug-in method to check if this is a solution, all right? So synthetic division is just a little bit faster, okay, for some problems. So synthetic division says, I'm going to put my answer form here. My answer form is -6, okay? And then I'm going to write these guys out. So my polynomial, highest power first, is x to the 3rd, so I only want the number, the coefficient. So x to the 3rd is 30. Okay, so I put a little note here. This is my x to the third guy. Then it has to go in order. I now need my x to the second guy. So if you look at your polynomial, it has your x to the second guy is 197. Okay, now I need my x guy, which I do have. It's 100. So if you're missing any of these x third, x2, x, they become zeros, okay? But in this case, we have them all. And then the last guy after your x is your constant, which is going to be negative 12. Okay, put our line here, and this is synthetic division. If it's a 0, we should end up with a 0 here. And this guy represents my remainder. We want a remainder of 0. This tells us we have a solution. Okay, so this is how it works. So take out your trusty calculator, because this can get a little nasty right now with all these numbers. Bring down to 30. Negative 6 times 30 is negative 180. (197 minus 180 is positive 17. Okay, so again, negative 6 times 30, negative 180. Now we're just going to do the adding and subtracting here. That gives me 17. And now we're going to multiply again. Negative 6 times 17. That gives me 102. Sorry, almost made a mistake. It's negative 102 because it's negative 6 times 17. Negative 102. And now we add this. This gives me negative 2. Negative 6 times negative 2 is positive 12. All right. And we have 0 because negative 12 and positive 12 is 0. So this is one way to check if this is a solution. Okay. So in this case, we would say yes, x equals to negative 6 is a 0 or solution or root, however they word that. Okay. It all means the same thing. So that's synthetic division, okay? It's a little bit faster. If you look at plug-in method, and it's very simple. Plug-in method you've probably done before. It's basically saying x is equal to negative 6, plug it in for x, and see if we get 0, okay? So plug-in method is just this. We're going to take 30, and instead of x, we're plugging in negative 6 to the third plus 197. Instead of x, it's negative 6 to the second plus 100 times negative 6. Again, we're just doing something you probably did in IM1 minus 12. And now we're just going to solve this doing PEMDAS. And our goal, if this is an answer, if this is a solution, our goal is this whole thing should equal 0. Okay? So we want this entire thing, after we do all the math, equal to 0. So let's check it out. PEMDAS says parentheses first. There's no parentheses that are grouping. So now we got to do the exponent. So 6 or negative 6 to the third power. That's 6 times 6 times 6. That's 30 times 216. So we'll leave it there. Plus 197, negative 6 to the, sorry, let me back up. This should be negative 216. Okay? Almost forgot my negative again. So that's negative 216 if you do the math correctly. Here, negative 6 times negative 6, that's positive 36. So 36 goes into parentheses, it's positive. And then plus 100 times negative 6 minus 12. Okay, careful with your signs. I almost messed up again with my signs. Now we're going to do the multiplication. So it's 30 times 216 or negative 216. We get negative 6,400. 480. Again, I'm not doing this in my head, guys. I'm using my calculator. And now we're going to go positive 197 times 36. 197 times 36. That gives me positive 7,092. And then 100 times negative 6. That's negative 600. And then minus 12. All right, and now we're just going to add and subtract from left to right. So 6,480, negative 6,480, plus 7,092. Okay, I'm throwing this all in my calculator. That gives me 612 minus 600. So minus 600 from that, and then minus 12 from that. And guess what we get if we do this math? We get 0. So these are the two methods. Once you have it in answer format, okay, you could use this method, synthetic division, or you can use plug-in method. But basically they're asking, we want our answer at the end to be 0. Okay? So I'll let you handle number 11 if you want. Well, it's an assignment, so you got to do it. All right, let's move on to the next section. Number 12. Again, this is something we did in Zoom last time. Okay, so this is our divisor here at the bottom. And they want to know, can you have a remainder of 16? So this is perfectly set up for synthetic division. But remember, our divisor right now is in poly form. Notice how it's not like x equals. This is in poly form, polynomial form. To use synthetic division, we got to transfer it into answer form. Okay, to do answer form, we're going to set it equal to 0 and subtract or add or solve for x. Okay, so keep that in mind. This one's a little tricky. Okay, so if you watch, what you're doing here, we're going to do synthetic division. So now that I have it in answer form, I can put my answer form here for the divisor. But if you notice, we're going to go from power of 3, so x to the third, but it doesn't have a number, it has a k. We have to decide that k value, okay? Then we want x to the second, which is not there. If you notice, there's no x to the second, which means we got to put 0 in its place. Then we want x value. It does have an x value, which is going to be, the number in front is 1. And then my constant is actually negative k. Okay? So what we want to do is we want to figure something, a number for k out, that when it's all said and done, I get negative 16. So I like these, they're kind of like puzzles. You can choose any number for k. So if you plug in 2 here for k, this is also negative 2. And you're going to do the math, okay, to see which one will give you negative 16. So we want to know what k is to give you negative 16. Try it out. It's a little puzzle. You got to figure out k so that when you do synthetic division, it gives you negative 16. If you truly want to see the answer, it's in the answer link. You can check it out. Okay? So try it, see what you get, and we'll go from there. Okay, 13. So I want to go over 13. It says, show that x plus 1 is a factor of this function or polynomial. This is not a typo, it's x to the 42nd power. So remember, this is in poly form. Okay, and we want to convert it into answer form, because answer form gives us more options to figure out if this is a solution or factor. So we want to turn it into answer form. Okay, so what this is really saying is x plus 1 a factor? So basically, can x plus 1 divide this evenly? Well, what we really want to do is we want to think of it as when we turn it into answer form. So let's turn x plus 1 into answer form by setting it equal to 0 and solving. So answer form is x equal to -1. So what we're asking is, once it's in answer form, is this a solution? So this now, since we have it in answer form, is very, very, very similar to what we did here for problem number 10. See how we have it in answer form? All we want to do now is check, do I have a remainder of 0? So we can use synthetic division, or we can use a plug-in method. Okay, and there's actually one method for number 13 that works better than the other. So what we're asking now, once we convert to answer form, is -1 a solution to this? Okay, and the answer in order to do that is we have to have zeros at the end of synthetic division or at the plug-in method that we just did for number 10. Okay, if it is a solution, then we know that x plus 1 is a factor. This is just another way of testing it. But here's the thing. If I do synthetic division, right, -1, okay, our highest power is 42. So we have x to the 42nd. The number in front of that is 19. Okay? We then, once we have our higher power, we got to then plug in x to the 41st. We got to go in order. Which would, if you notice our problem, we don't have x to the 41st. That means we're going to put in 0. Then we'd go x to the 40th. We don't have x to the 40th, so it's 0. And then the x to the 39th. Do we have x to the 39th? No, it's 0. X to the 38th. No, it's 0. So if we do synthetic division, you can see the pattern. We're going to have a bunch of zeros until we get to just x. So imagine a bunch of zeros here. And then finally we get to x, which is going to be 18. And then our constant, which is going to be -1. So what I'm trying to say is synthetic division is not an efficient way of checking if this is going to give me a 0 at the end. Because if it gives me a 0 at the end, that means we have a factor or a solution. Okay? So as I look at this, the more efficient way would be the plug-in method. Because all we would have to do is plug in -1 into x and do the math. And our goal is to have 0. So I prefer, for this particular problem, let's check the plug-in method. Okay? So we're going to take 19. Instead of x, we now know x is equal to -1 because of this. We solved for it. We made it in answer form. So it's going to be -1 to the 42nd power plus 18 times -1 minus 1. Okay? And remember to check if this is actually a factor or an answer or a solution. We want all this equal to, eventually, if we do the math correctly, we want it equal to 0. If it's equal to 0, then we can say this is a factor. All right, so we're just testing to see if it's a factor. So let's do this math. PEMDAS, parentheses first. We don't have parentheses that mean grouping. These are not grouping parentheses. Next is exponents. So -1 times itself 42 times. So negative 1, negative 1, negative 1 times 42 times. So negative 1 times negative 1 times negative 1. Since it's even, negative 1 times negative 1 is actually just 1. Because the power is even, that means we're going to have all that just turns into positive 1. If you don't believe me, throw this in your calculator. Negative 1 to the 42nd power. Okay? 18 plus 18 times negative 1. There's no exponents there. Minus 1. All right? So let's do some math over here because I'm running out of room. Let's switch it up here. 19 times 1 is 19. 18 times negative 1 is negative 18. And bring down the negative 1. And now we can add and subtract from left to right. 19 minus 18, that's 1. Bring down the negative 1, and guess what we get? 0. Since the plug-in method equals to 0, that means this is a solution, which means when I turn it back into polynomial form, which I have here, that means this is a factor. It divides it evenly because we have a remainder of 0. Okay? And that's pretty much it, guys, for today. So let me just sum this problem up, because if you understand this, this is exactly where I want you to be. So to check if it's a polynomial is a factor, let's turn it into answer form and do one of these methods. And ultimately, whichever method you choose, our goal is to get a 0 at the end. Okay, if it's plug-in method, we want our problem to equal 0. If it's synthetic division method, we want our remainder to be 0. If it's 0, then we know that this is actually an answer. And more importantly for this question, if it's in polynomial form, it's a factor. So it's just a way to test the factor. All right. If you need extra help, stay on. If you have questions, stay on. I'm going to get you the check-in code and get you out of here. All right. Get your stuff done.